Welcome to AI Frontiers. Today's episode synthesizes insights from 137 computer vision papers published on the arXiv preprint server on December 12, 2025. We explore the field's transition from simple recognition to deep understanding and the critical challenge of bridging laboratory brilliance with real-world reliability. This journey maps the collective consciousness of computer vision. We'll identify the dominant themes pulling the field forward, spotlight groundbreaking findings within dense research text, and read the tea leaves for AI's next decade of evolution. Whether you're a developer, researcher, or AI enthusiast, this analysis serves as a diagnosis of technology in hyper-evolution. Computer vision is no longer just image recognition. It's AI's foundational sensory layer. It serves as the eyes for robotics, healthcare, and entertainment. Every advance here ripples through the entire intelligent ecosystem. The field now tackles hard problems after the low-hanging fruit is gone, focusing on robustness, understanding, and creation within messy reality. The first dominant theme is enhancing robustness and generalization, which addresses AI's Achilles heel of brittleness. Research like OMETA uses hierarchical masking for cross-city adaptation in autonomous driving. The Adaptive Detector Verifier framework prioritizes never miss in medical applications like polyp detection. This work isn't about benchmark scores. It's about ensuring systems work when it counts, engineering reliability directly into AI systems. Theme 2 is efficiency and architectural innovation, focusing on doing more with less in the age of scale. Grotas trains vision transformers progressively, like building a skyscraper one floor at a time. Speed-running ImageNet Diffusion achieves top-tier image generation quality with a model that's a fraction of the size. This addresses the walls of physics and economics faced by ever-larger models, democratizing access to high-end AI. Strategic pruning and token routing represent masterclasses in computational efficiency. Themes 3 and 4 focus on multimodal and three-dimensional understanding, moving vision into context and volumetric reality. VideoARM is an agentic reasoner that builds hierarchical memory from long videos. Another innovative approach uses passive ambient sound to estimate camera position when the visual signal fails. Endless World aims at generating infinitely long 3D consistent videos, while ArtGen creates articulated 3D models with correct movable parts. The future of vision is clearly multisensory, volumetric, and dynamic. Several key findings represent elegant aha moments. MetaTPT demonstrates that meta-learning can supercharge test-time adaptation, creating sample-specific augmentations like a personal trainer for each piece of data. Vegas grows language generation in vision by injecting a vision model's own attention maps into the language model, effectively whispering, "Talk about this part," to reduce hallucinations. VideoARM's agentic paradigm enables efficient understanding of long videos by deciding what to process and when. The methodological toolbox is rapidly evolving. Diffusion models and transformers form the power couple for generative tasks, though they face immense computational costs. Attention mechanisms and graph networks serve as the glue for modeling relationships in non-grid data. Test-time training has shifted from a niche trick to a vital tool for robustness. Retrieval-augmented frameworks look information up instead of cramming all knowledge into parameters. Each tool offers strengths but faces limitations in scaling or inference cost. A standout paper is Advancing Cache-Based Few-Shot Classification via Patch-Driven Relational Gated Graph Attention by Tazweer Ahmad and colleagues. It tackles specializing giant models with just a handful of examples. The key insight is that the discriminative magic lies in the relationships between image patches, not just the patches themselves. Their method uses a relational gated graph attention network to learn these patch-to-patch relationships. The killer feature is that all complex graph reasoning happens only at training time to build a supercharged cache, enabling lightning-fast lookup at inference with zero runtime overhead. It was validated on a poignant real-world application, injured versus uninjured soldier recognition for drone-based search and rescue. The seminal paper in medical AI is Adaptive Detector Verifier Framework for Zero-Shot Polyp Detection in Open-World Settings by Shenkai Su and team. This addresses the high-stakes environment of colonoscopy, plagued by motion blur and poor lighting. The proposed two-stage framework, Adaptive Detector, uses a fast geometric detector to propose regions and a slow semantic verifier, a vision language model, to guide it. Crucially, the verifier is fine-tuned with reinforcement learning, using an asymmetric reward function that brutally penalizes missed polyps far more than false alarms. The AI was stress-tested on a synthetic benchmark with realistic adverse conditions. Results showed a 1,4 to 22 percentage point boost in recall, potentially saving missed polyps while maintaining respectable precision. Another seminal paper is Endless World, Real-Time 3D-Aware, Long Video Generation by Zhang and collaborators. Its goal is to conquer the temporal drift that plagues AI-generated videos. The methodology rests on two pillars: conditional autoregressive training for long-range temporal coherence, and a global 3D-aware attention mechanism injected throughout generation to enforce spatial consistency. This approach is efficient enough for real-time inference on a single GPU. The significance is monumental. It represents a step from merely generating short clips towards simulating persistent, navigable digital worlds, pointing the way to future generative world models. Looking ahead, the path is lined with both dazzling opportunities and stubborn challenges. The reliability gap, encompassing hallucinations, domain shift, and temporal drift, persists. The resource divide, requiring massive data sets and specialized hardware, continues to centralize power. Key future directions include agentic and embodied AI, where models act and explore, not just see. Hyperspecialization will lead to an ecosystem of finely tuned experts rather than one-size-fits-all models. The ultimate convergence will integrate vision with language, audio, geometry, physics, and knowledge bases for true comprehension. This presentation was created through a synthesis and review process. Content was synthesized using GPT models. Audio narration was generated via TTS synthesis. Visuals were created using image generation models. All content underwent professional human expert review. An important caveat is that some oversights may still exist despite this rigorous evaluation process. Subscribe to AI Frontiers to stay on the cutting edge of AI research. Join our community of developers, researchers, and enthusiasts for weekly deep dives into the latest breakthroughs. Understand where technology is headed before it arrives. Find us on YouTube under AI Frontiers, where we specialize in synthesizing complex research into clear, actionable narratives. 3 key takeaways emerge from the collective message of 137 papers. First, robustness is the new accuracy. Performance in messy reality matters most. Second, efficiency is a first-class citizen. Sustainable and democratized AI depends on doing more with less. Third, understanding is multisensory and active, marking a shift from passive recognition to agentic comprehension. The field is transitioning from exploratory adolescence to engineering-focused adulthood, building bridges from pristine trading data to chaotic real-world application. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.